So today we're going to take a look at standard deviation, which is just another form of a measure of spread. So it tells you how different the data set is from one another. So similar to the range, the higher the standard deviation, the more variety you have in your data. We're going to take a look at the bell curve, because what the bell curve shows us is standard deviations away from the mean. So when we look at this center of the bell curve, and this is a normal distribution of data, so for things like IQ, most people, in fact 68.2% of people, if you look at these two, fall within one standard deviation of the mean, either above or below. Once we add on the second standard deviation, that 13.6% of people, sorry, that's an S, either two standard deviations above or below the mean. When we count all of this, that includes 95.4% of people. So the vast majority of people or items or things, whatever data value you're looking at, typically fall within two standard deviations of the mean. When you're looking beyond that, you're getting 4.4% are either more than two standard deviations above or below the mean. So these are what we would call outliers. Now when we first looked at outliers, we kind of eyeballed it and said, well, that looks a lot bigger. Now we're going to find a more precise measurement for what exactly is it that we're calling an outlier. It would be an outlier if it's not in that 95.4% of, quote, normal items on the list. We're going to start with a real quick review of range. So for this, all we need is the highest data value and the lowest data value. So looking through our list, our highest phone bill was 48, and our lowest phone bill was 29. So that's a $19 range in our data set. So what you want to ask is, does it seem reasonable for the set of data? 19 could be a really large range for one data set and a very small range for another data set. When we're talking about phone bills, I would say this is a fairly large range because you tend to use your phone the same amount each month. So a $19 difference between your highest phone bill and your lowest seems rather large. That word is similar, sorry. Let me rewrite that, similar. All right, so as I mentioned, it seems like a large range when your phone bills tend to be similar from month to month. Now we're going to take a look at standard deviation, and I have several examples so that hopefully by the third example, if it's not making sense what we're doing, you'll catch on. If you catch on after one or two examples, feel free to jump to the U try. All right, so first step, does the standard deviation seem large for the data set? Okay, so what I want you to picture is this bell curve. We've got our mean or our average in the middle. So that's 44 home runs was the average for the people who scored the top 10 most home runs. Our standard deviation is 4. So if we add 4 and subtract 4, if you remember that first bell curve, about 68%, I believe 68% of the data should fall from 40 to 48 home runs. As we go out from there, that's 2 standard deviations. 95% of the data tends to fall within 2 standard deviations of the mean. If we have any data in our set that's below 36 or above 52, we would call those an outlier. But I actually kind of got myself sidetracked there. First, is the standard deviation large? I would say for number of home runs, when you're talking about the most, 4 doesn't seem like a huge number that would make this a large standard deviation. So I would say the data is fairly similar based on the small standard deviation. and I'm going to abbreviate SD for standard deviation. So now, going back to my diagram, here's how you determine if you have outliers. You can either do like I did and just add 4 and subtract 4 twice, or you can multiply your deviation by 2, so 4 times 2 is 8, add that value to the mean, which would give us the 52. So looking through, do we have any data values higher than 52? And the answer is no, so we have no high outliers. So then we take 8 and we subtract it from the mean, which gives us 36. Do we have any data values lower than 36? Again, no. Looking at our list of data values up here. So we have no outliers in this data set. Next example. Here's a list of data that's wait time at the DMV in minutes. So the average wait time at the DMV was 7.2 minutes, and the standard deviation was 3.5 minutes. 3.5 minutes for wait time doesn't sound long to me, so I'm going to say that this is a small standard deviation, so the data set is similar. Alright, so now instead of using the bell curve, I'll show you kind of the formula I have for you. You take the standard deviation, multiply by 2. 3.5 times 2 is 7. Add that to the mean. And then look through your list of data values. If any data values are higher than a 14.2 wait time, that would be an outlier. And the highest time that I see is 14, so it doesn't look like we have any high outliers. And then you would take that same value with 7 and subtract it from the mean. And there was no wait time that was less than 0.2 minutes. Everybody had to wait at least, it looks like, 3 minutes. So no outliers. Last example, again, let's analyze that standard deviation. I'm looking at a standard deviation of $72. And when we're talking about the price of a cell phone, that sounds fairly large to me, that the difference in prices would be $72. So I'm going to say high variability. That just means the data set, the phone prices are highly different from one another. They're not all similar, they're not all grouped around the same amount. They have a wide range. And as you look through, you can see that. We've got a price of $35 and we've got a price of $300. So we have a high variability in the price of our cell phones because large standard deviation. Okay, so the process for finding the outlier, you take the standard deviation and multiply it by 2. We're going to take, if we took our mean and subtracted 144, we'd get a negative value. So we actually don't even have to look at that. There were no cell phones that they paid you to take. So now we'll take our mean and add that standard deviation times 2. That gives us a total of $283.50. So if there were any data values larger than $283.50, those would be an outlier. And of course, the $300 phone catches my eye. I don't see any others that are that large. So the $300 phone is an outlier. And go ahead and try this one before you come to class tomorrow.